My name is Wellington Chaora, a Zimbabwean, a community ambassador from ALX, and I'm here going to moderate this session, and we are going to get right into our session agenda for today, because this is what you guys are for. You want to know what's gonna be like in this session. So we are going to give our introductions, our check-in prompt, and we are going to introduce to you guys our guest for this session. And after that, I'm going to hand you over to somebody who is going to introduce our guest for today. And then after that session, we are going to have a fireside chat, a panel discussion, and then we are going to have a Q&A after that, and then we do our announcements, and then we close. That's it, guys. So I am going to ask you guys, this is the check-in prompt for today. Now, I want you guys to tell me in the chat, I want to see, I'm opening the chat right now, I'm looking right at it. Which industry's use of machine learning are you most curious about? I see agriculture, I see healthcare. Two healthcares there, yes, I see them. Let's keep them coming. I see healthy. Yes, healthy. Health is coming. Yeah, health is taking the toll here. Yeah, finance, banking. Oh my goodness. Environment, healthcare. Yes, that's fintech. Oh my God. This is great, guys. Sports, business. Yeah, I see them coming. Keep those messages coming. Creative industry, image and audio, technology, trading, betting. Okay, is that a question, Shagun? Because I can't really figure out whether that was just a say. But anyways, guys, this is great. This is interesting. We are going to know more about everything machine learning today. So at this moment, I'm going to call upon one guy, the program ops guy that we have, our very own program ops, and he's gonna come and take the stage here. He's gonna take the stage up to the end now. But let me introduce you to the one and only Obasinachi Eleonu, our program operations associate. Uba, this is for you, my guy. But before I hand you over to Uba, let's just give him a round of applause, guys. I want to see a round of applause. Some love. Let's show some love. Yes, some love for Uba before he comes. Yes, I can see the hands. I can see the clappings. I can see the hearts. I can see everything, guys. Let's keep them coming. Uba, are you there, my guy? Please be on the stage and take us through our guest introduction.
All right. Thank you, Wellington, for that introduction. You always amaze me whenever you do your introductions. All righty, without wasting any further time, can we move on to the next slide, please? So I'm just gonna start off by introducing the very first of our special guests, who is gonna be be one of the speakers for our fireside chat. And before I go into his bio, for those who do not already know, this speaker is not just any speaker. He is one who has been on this side of the fence, and he definitely knows you, or knows so much about everything we do here. And to add to that wealth of experience, of course, he brings on his experience from the industry, right? And that's why this is very important for every one of you to, be very much present in today's conversation. Make sure you listen attentively to everything he's going to share. He's sharing from a wealth of experience across both academia and industry. Without further ado, allow me to introduce our special guest, or one of our special guests today, by the name Damien Veta. Okay, I'm not going to try to pronounce that because I always struggle with it. But yeah, let's straight into his profile. Damian is currently the head of data and AI strategy for the corporate and investment banking division of one of Africa's largest banks. And his experience spans across both consulting and lecturing. Like I did say earlier, he He has a mix of both academia and industry. He's a seasoned data and AI leader with 8 years of combined consulting and lecturing experience. And in his current role, Damian drives strategic initiatives to first unlock value from data, also elevate analytics capabilities, and of course, embed AI into decision making across businesses. Damian is very passionate about empowering organizations through intelligent insights, of course, from data. And his approach is basically to combine both academic with hands-on delivery to successfully build data-driven cultures and future-ready platforms. Please, if your hands are not too busy, join me in welcoming Damian to our fireside chats today. I'm not gonna move on until I see all of them emojis. Okay, I see them coming. Keep it coming, keep it coming. All right, awesome. But of course, we don't have only Damian with us today. We've also got another wonderful speaker in our midst, one who I believe you're all very familiar with. And if we can move to the next slide, please. All right, so allow me to welcome Buhari Shehu. Buhari Shehu is a data scientist and technical mentor here at ALX. And a bit about Buhari. Buhari is an educator and a mentor. He has his background in electrical engineering, and he's very passionate about data science and education advocacy. Buhari has successfully taught and mentored thousands of learners across multiple platforms, and I'm pretty sure you all on this call are one of those learners who he has impacted through teaching. He proudly contributes to a measurable increase in learner success rates. Buhari's mission and impact is very much rooted in empowering African youths to confidently step into data roles. He's also focused on helping learners realize their potential, build confidence, and then turn challenges into opportunities. And overall, he aims to tackle important African and global challenges through data literacy. A very interesting thing about Buhari, beyond mentoring, Buhari enjoys navigating and exploring the universe and watching movies. I'm trying to remember some very interesting thing he told me about where he wants to go to, and I had to remind him of his family because I mean, it's one thing to be very adventurous. It's another thing to also remember, you have people who still look up to you. So yeah, Buhari's core belief is this: simply put, start where you are, use what you have, and keep going because you're capable of more than you think. So again, once again, if your hands are not too busy, please join me in ushering in our second speaker for today's fireside chat, Buhari Shehu. All right, I see the emojis. Welcome, welcome, welcome. So before we get right into the serious stuff, maybe let me just allow our wonderful speakers say a bit of a hello to us. And I'll start with maybe a fun fact about them. Damian, if you want to share with us a fun fact about you before we dive right into the serious stuff.
Fun fact on the spot. I think I'm probably an undercover Lego addict. I love sort of building Legos, childhood fantasy. I think it gives me that space to feel like a child again with all the stresses of work in general. So I guess that's my fun fact. And then I'm also, I guess, a karate expert. So black belt data scientist and black belt in real life. So I guess that's my fun fact.
Awesome, awesome, awesome. Buhari, do you want to share beyond your adventurous spirit? What's the fun fact about you?
Oh, so as for me, I like, just as you mentioned, I like exploring nature and most especially like exploring the bushes around me to see some fruit and pluck them myself to eat.
That's interesting. All right. All right. So I'll just start right up. I got a question, and I think it would be nice to hear perspective from you both on this question. So my very first question would be, um, can you like looking back at your journey so far, right? Can you tell us about what it's been like? And I'm speaking specifically your journey through machine learning. What has it been like? At what point did you get started along this journey? And what is it that drew you specifically to this field? And I will start with Buhari because I see that you have a background in electrical engineering, something that I also used to have a background in. So yeah, I'm sure the learners would want to hear, how did you go from being an electrical engineering, I mean, from studying electrical engineering to practicing data science and by extension, machine learning today?
All right. So, as for me, as you mentioned, right from my experience with data, because I work as the examination officer of my department. Then back then when I was lecturing in a polytechnic, so I used to be amazed with how with little effort you can gather a lot of information from the student data that I work with, and I was also fascinated by the kind of technologies that you can easily use to achieve that. Most especially, then I was using Microsoft Access as a database to manage learner records. So that triggered my intuition to dive deeper into the world of data. And not only that, also like trying to be relevant in the 21st century. So I saw one report that data is one of the most sought after skills in this 21st century. So I was just trying to like combine my electrical engineering skills with data and trying to see how we can bring out newer solutions to the problems that are facing, okay, to the problems that are facing humanity. So yes, that's how I got into data science or machine learning.
All right, awesome, very interesting. Okay, I'm just going to pass it on to Damien now. Damien, please tell us what your journey has been so far, your journey through machine learning, at what point you started, and what the journey has been like thus far.
So in terms of where it started, I think, funny enough, it was also doing student analytics. We were trying to predict how well a student will do in our course based off their entry requirements. So kind of help us calibrate, good students, see where we need to sort out and help other individuals. I guess that was the first taste of it, other than a, school project that you get to work on. And from there, it's been evolving. I think now a lot of people are in the space of agentic AI, which I still think is very far away from industry. At least from what we've seen, is that we're struggling to get the right stakeholders in, to get the right trust, security. It's quite a big space, and I think AI as a whole has been evolving. And where we sit in this world at this moment is that people tend to use the word AI when they don't know what the actual solution is. So we used to call AI back in the day, where we used to do natural language processing and machine learning, which was like regression modeling and classification. And once we knew what it was called, we don't call it AI anymore. We call it linear regression. We call it classification. We call it chatbots and so forth. So I think that's something we're seeing in the world, is that anytime someone wants to sell you something that doesn't exist, we use the word AI, and then we bring it back into reality once it all shapes up. So that's, I guess, the journey is just evolving in the very rapid world of sort of machine learning and AI as we discover it, learn, and enhance through the space.
All right, awesome. I do agree with you. AI is fast becoming a buzzword. People throw it in here and there, even when it's not exactly what it is they're talking about. All right, very interesting one there. One thing, it's funny how there's a correlation between where you both your journey started, and even more importantly, the fact that it had to do with it was within academia, within the academic space, and very, very relevant to today's conversation, seeing how we are talking to learners who are currently in their learning journey. All right. So Damien, I'm just going to put you on the spot again, if you don't mind. Were there any pivotal moments or challenges that you faced in your career that shaped how you approach um, your or how your interest in machine learning today? Were there any challenges back then? I know you had talked about how you started off while trying to analyze student data, but beyond that, were there challenges or pivotal moments that pretty much changed your whole perspective towards ML?
Yeah, so I think I've always enjoyed the world of statistics and knowing that you can always put like a maths model to something and it kind of gives you something out. In terms of big turning points, I would say when I first started, the big turning points were every few months because then someone came up with something new. There was a new, better algorithm that someone developed. And now I think the turning point is every single week, just because of how fast everyone is moving forward. So I think it's a never-ending journey. The challenges have always been the same, is that there's overhype of all the new flavors of machine learning and AI and generative AI, and sort of being able to process that information, understand what's actually happening, and then using it in your space and communicating with your stakeholders, when do they actually get to use that? And from what we're seeing, and we'll talk about it a bit later, is, you know, everyone wants the new toys, but they actually need to just start at the basics. And the basics is what lets you play around with all the cool tools that are coming out. But that foundational machine learning is always key. So all the stuff you guys learn in the course and so forth still play very important factors for businesses making that first analytical decision and first understanding their data before they can do the wonderful new stuff of sort of orchestration and so forth.
Awesome. Awesome. Cool. Um, I was going to ask a follow-up question on, I mean, saying how there's some learners here who do not necessarily have that statistics background and they tend to struggle coming into especially the current machine learning track. What are some, just off the top of your head, what are some quick tips you could give them on how to be more disposed towards learning statistics, seeing how it's a very important or requisite knowledge for machine learning?
Okay. I mean, maybe to give context for those that are very scared about everything stats related and machine learning, I didn't know how to code before joining the course, just FYI. So I learned that quite quickly over time. And I think it is intimidating at the start when all these new terminologies are coming, but start small. So one of the projects I'll actually show you guys later, if I had to ask you guys what is the average of 1 plus 2 or 1 and 2, you guys will add 1 and 2 together, you'll get the number 3 and you'll tell me the average is 1.5, right? That's quite simple maths, right? But would you believe me if I told you that's implemented in industry to work out a recommendation engine? Quite simple. So in essence, depending on how you're starting, where you believe there's value, you can start with the most simplest of implementations that have extreme value for your client. So it's quite important that you take your time just learning the basics, practicing, enhancing before you jump into the big stuff, because the big stuff all require you to understand what is good data practice, what is understanding your variables. All that needs to be understood before you can use the tool in the end. So just start small and don't be scared to take the leap of faith, build a bad model. If your first model is 20% accuracy, still 20% better than the model you didn't build.
True, 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 true. Very, very spot on there. All right, thank you for that. So I'm just gonna move it a bit to Buhari. Buhari, I have a quick question for you, right? Speaking of projects, what was the first machine learning project you worked on? And what were your key lessons or takeaway from that very project?
Okay, so sometimes I used to struggle with questions like this, maybe most especially like when you ask me to give you one, because sometimes I may get so many interesting things that I want to talk about. So the first machine learning project I work with is back then when we were studying data science at Explore Data Science Academy. So if I could remember correctly, it is predicting the shortfall of Spanish electrical distribution system. So that's the first one I work with. And maybe one of the challenges I could say from there, what I understand is like you need somebody in the team that will be dedicated, because I think we ended up only being the two of us delivering the project. All other team members, team of 6, so all of them left or refused to contribute. So that's one of the lessons I learned there. But also, like apart from the learning side, like currently there are some machine learning projects that we are pursuing. One of which is using, that's fine-tuning a large language model, or LLM model, in order to serve answers or to serve the queries of our learners. So it is interesting, but there are a lot of challenges along the way, which I may not have time to speak about now.
No troubles at all. No troubles at all. I do recall the electricity shortfall project, and that was quite an interesting one for me as well back then. All right, Buhari, I'm going to stay with you a bit. Looking back, what are those skills or experiences that you think were most critical in helping you succeed in an ML in a machine learning project? Saying how, I mean, you touched on how, there were just about two of you on your team that were able to eventually get the project done. So from your own perspective, what were the skills that actually helped you to contribute meaningfully to that project? And then I'll bring it back to Damien on the same question.
Okay, so funny enough, maybe the skill might not be technical per se, because like right with the advent of this artificial intelligence, or when we are moving towards AGI, so the main focus is now on the soft skills. So I think maybe the best thing that will help you is, one, perseverance, then two, your approach to problem solving. And three, also your belief. So whenever you are confronted with any problem, you should have a belief that there will be a solution. So once you have that belief, then your own is just to look at how to get that solution. But when you are confronted with a problem and you start thinking that, oh my God, where is this possible? How can I solve this? Then there is a fundamental problem there. So you should be persevering. Then two, you should also have a good problem solving skill, and also that you should have a belief that there will be a solution. Then we dive in.
Right. Awesome. So I'm just going to roll that over to Damien, and I'll start with, what are those skills or experiences that have been very critical in helping you succeed in your current role, right? And just a follow-on question in that, Damien, how, I mean, my presumption is that you have, in your current role, you have had to build quite a lot of machine learning models. So how do machine learning models impact decision making and operations in your current role or in your organization?
Cool. So from a skill side, obviously there's the technical side, which I think, it's covered in every textbook better than I can explain it. So you've got a whole set of algorithms that fit specific niches and problems. And often now with how well, and to be honest, in industry, how well these LLMs work is you can actually ask them which model you should be using. While they won't build it for you, it's good to just bounce the ideas, because it's just quicker, right? It's the best library of the 21st century, right? So that's simply how you get your technical thing, and then you would learn a given chapter on that. You'll learn how it works. But more importantly, before you even learn how to model or build any machine learning things, is actually to understand what the true problem is that you're dealing with. Often people are running headfirst to throw the most complex solution at it. They want complex modeling because that's what they heard worked. But sometimes it is as simple as it can be in terms of just adding numbers together and showing it on a dashboard. It can be as simple as extracting data from a document and landing it on a database so that someone can see it better as opposed to an ugly PDF. So there's a lot of things that take time to understand the true problem you're dealing with. And once you have that, you then need to accompany that with your skills that you've learned over your career to then build the correct solution for the given clients. And then in terms of how machine learning shapes the business, I think it's best to go into sort of the slides to talk through those use cases. But typically, you want to know the problem area of your client very well. And once you have that, you address that with a machine learning solution. So in some cases, it's a chatbot in which then helps your customer engage better with the team without always needing them to contact a call center, because that's quite time consuming and a chatbot never needs to sleep. Sometimes it's about automatically responding on an email. In other times, it's about building a recommendation system that suggests the next best product for someone to buy. All of this is around optimizing the way in which people work through the space, as opposed to just trying to build the first solution you can think of. So the decision making all comes to play as we sort of go into the space. I'm not sure this is the segue in which for me to present and take them through some of the more technical details. I'll give that to you, Sinachi, to let me know.
Yeah, absolutely. Absolutely. I think I was just going to ask you a question that, we take on right into it, and still building on, how it drives, or how machine learning models drive decision making. I think one thing a lot of learners here are curious to, find out, and we saw that even from the checking prompt, would be which industries or, business problems do you see machine learning having quite the biggest influence or impact in today?
In today's day and age, I think it's across every industry. So currently, and I guess if you go to the next slide, and then I think that segues into it,
Yeah.
every industry requires AI solutions, right? It's not necessarily restricted. So I think people in the chat are asking, where do you operate? Like, what do we want to hear about? So from healthcare, there's use cases around basically ensuring that when people submit their medical aid details and they submit a quote for a claim, that it is valid, that it's not a false claim, that it's not overpaying and so forth. So that's one of the use cases in the healthcare space. We're looking at the side of things like Investec, which look to help optimize the way in which they receive trade information and ensuring that their trades are accurate, that there's due diligence put in place. Coca-Cola is a brewery company. I'm sure everyone knows about them. They wanted to basically, instead of you always needing to tell them what you want to order, they will actually tell you what they think you were going to order already. So that's sort of a suggested orders engine that was built. So every single industry requires it. There's no one that's better. In the sense of where do you get the quickest impact is those with the willingness to adopt change, because it's not easy to go in and build machine learning solutions. It takes a lot of maturity. It takes data governance. It takes ethics. It takes your NFR, which is your non-functional requirements, a whole lot of things to come through and get into the space. So I guess now we'll hop into full presentation mode. So if we go into the next slide, I'll take you guys through some of the journey. So where do we sit as sort of machine learning engineers and solution architects and designers, right? So often in good corporates, we've got your executive level, right? These are your CEOs, your CIOs, and all the people that make decisions, and they have a vision for their business. So they often give you the objective and value they want, right? They will tell you very specifically, I want to make this amount of money, I want to improve process flows and so forth, right? So that's how these things work, right? So they will give the enterprise architects, and these are senior individuals with domain expertise that know how things work, right? And what they do is they take direction from your security team, from your tools team, your infrastructure team, and they very much say what you can and cannot use, right? So for example, we are not allowed to use ChatGPT in the bank, right? For example. However, we are allowed to use Microsoft's Copilot. So while it is different tools, you still get similar functionality out. And the reason behind that is because it needs approval, it needs to be vetted, and it needs to be controlled by the organization. So with all that information of IT strategy, business strategy, we formulate two key things. One is a data strategy for how data can be used and moved around. So very importantly, in the African regions, you are not allowed to just move data from one country to another. So in terms of understanding, are you allowed to consume someone's data? Are they willing to let you use it? All of these things are very critical points of discussion to ensure your solution can even be built. The data strategy will then inform your AI strategy, which is then, I want to build X, Y, Z models, and then you go forward and build it. Enterprise architectures then review that information, and then you have solution architectures, which sit underneath, and they're a focused individual working on a specific use case. And this might be whatever you need at the time that's been scoped by the team. So often the people on the field, on the job will say, I would like to build something to make my life better. They then will chat to the solution architect, and together they formulate a plan. And that plan goes to the enterprise architects, and then they say, cool, go and build your solution. And this is typically how it works in the big corporates. In smaller companies, all that will happen is that you will not have this enterprise architecture level. You'll simply have your solution architects building very closely with your project teams. So you remove a layer of security, but in the good space, what enterprise architectures are meant to do is they give you the delivery standards for building and execution. They ensure the tools are governed, secured, and validated from security and governance. And then they ensure guardrails are in place. So often we need to ensure that the use case is ethical and it's responsible. And often when we're building solutions, people forget about that. And I thought there was quite a nice comment when someone asked about betting the industry. People go, using AI and betting is quite unethical. No, we still need to know if a client is happy, if a client is engaging with our platforms well. We also want to know what's the next best game for them to play. That is not an unethical use case. That's a client experience being made better. So again, what might seem as very strange industries to work in, there's always value to be brought in. You just always need to make sure it's ethical. But if we're building a use case to keep people playing on a slot machine longer until their money runs out, that's then very unethical, right? So you have to play your cards very well, and you take leadership from the people in the space. And then sort of lastly, it's they ensure the strategic alignment and value-driven proposition. So they know what the CEO wants. Because when your company is 1,500 employees, which is ours, I can't chat to the CEO. I don't earn enough money to chat to him easily. So I have to go via channels to get that mandate through. So often they help filter information down to ensure that it is relevant to your team, your individuals, and it sort of helps you navigate that corporate landscape. Cool. So next slide, please. All right, so in essence, what we try to build is this AI house. It's what makes a project successful in its most simplest state, right? So what we're trying to do with any solution we're bringing is switch solutions and IT from being very reactive to being proactive. And that's what machine learning is meant to do. We're trying to forecast the next incident. We're trying to predict what could happen. We're trying to make assumptions of the world we live in and create simulations from it. And it all starts with putting out our foundation of quality data management. Bad data means bad models, right? No matter what you try to do. An easy example to show you with words, if I tell you I've got 5 white cars, can you tell me what the 6th car is going to be? And you can put it in chat, right? For the most part, I think most people will assume the 6th car is going to be a white car, right? Because every other car was white. In theory, that's what the machine learning model is going to think. But fun fact, the 5th car or the 6th car was actually just a red car. Weird, and you would never know it because you didn't see it. So ensuring the good data is there helps you move forward. Next, we've got monitoring. Anything you want to do, you need to be able to see it. So making sure you can monitor your data, your workflows, anything, whatever it might be, ensure you can see it and it's visible. Next, we create something called infrastructure as code, which is ensuring that your pillars, your building blocks for machine learning is all in place. So your cloud infrastructure is in place, your AI platform is in place, your data lakehouse is in place. All the elements, you build them out as code, as opposed to just having manual setups happening all the time. You can't be building good machine learning solutions on your local PC. Doesn't work like that. Everything needs to be cloud orientated, or at least being built in a sort of solution that's built for scale. We then want automation to be quite key. If you're not automating, then what are we doing, right? We're quite lazy, I think, as individuals, and the key thing is for us to focus on improving things that are repetitive in nature. And then lastly, the actual thing that we all like, and that's why we're probably here today, is AI and machine learning engines, right? Building the actual model. But there's no point building a model if you can't see its impact. There's no point building a model if it's not being deployed onto cloud. There's no point building a model if you're not planning to automate long term. And the next action is then to create a communication layer where all this insight and information is produced and shared with people so that they can make an informed decision to then drive actions. And that's a very simple building blocks of building out an AI solution in industry. And this is something we go across any standard. So if we go into the next one, we can look at some of the key work areas. So how do we go about creating a solution for any client? And as sort of Buhari mentioned, and sort of every other speaker you might have heard of, it's actually understanding what we need to do. It's a softer skill. So we often start with the double diamond, which you might have seen in your classes already, but we have a proposal that comes through from someone. We then spend time to discover and understand, why does this even exist, right? Why did you want to go and solve the problem? We then try to define the problem and articulate it back to the client to be like, do you understand that this is what we think of your project, and are you happy with the way forward? From there, we create a proposal round 2, when we describe the how and what we are going to solve. So we develop a little bit of a POC, and then we'll deliver something, right? It will be an iterative approach. You'd have heard of agile methodologies and so forth, to then finally come up with the solution. And this is typically the way of work in industry. There are different businesses that use different approaches, but fundamentally it's all about just understanding the problem. So let's look at it into the next details a little bit further. So next. So the AI hierarchy of what needs to happen and where actually our work plays in. 40% of time, this is not an exaggeration, is spent on data infrastructure. You cannot build any AI without data. And it takes months to get the data right, to get it from the right channels, especially when trying to build it at a corporate level, right? It's very easy to build it on your own machine when someone gives you your data and you just need to click download and then you say read CSV, right? That's quite easy. In the real world, you're working with APIs, you're working with databases, you're working with integration points, and you need to be very aware that data is not just coming from one entity, and you need everyone to be willing to share and collaborate. Next up is about 30% gets done with data quality and governance. Do I have the right data? Is the data usable? Can I even use the field? Fun fact, the other day I found a data column in my data set, and the data was called 10. And no one can explain to me what that 10 means. There's no data in it to tell me if it's useful or not. It has a mixture of numbers, and no AI can even tell you what they think the column is. So that's sort of problems you deal with. And these are in production data sets, right? So it's not just someone's fun data set that they made an error on. Next is sort of data plumbing, right? We're looking for getting the integration in, processing the data, cleaning it, building out some level of integration into your main system. And then we actually only spend about 10% of our time building a model. In fact, there was a 9-month project I was on. I built a model for 2 weeks out of the entire project. The rest of the time was documentation, getting the data in, understanding the domain. And only 2 weeks was spent building the machine learning model that sits in production, right? So you can see it's not just something that's on a slide, it's very real. And as you get into the workplace, you'll see these problems come through. Cool. Next slide. So when we look at like a very complex thing, and this on its own is an entire talk, but I'm not going to bore you to death. But if you want to build out the capability for building well-architected solutions, this is what you need, right? You need to be able to handle data sources from structured data, which everyone does quite well. Generally, those are tables and so forth. You need to be able to handle semi-structured and unstructured data. So those are JSON objects, it's emails, it's text. That's all your sort of unstructured data that you need to be able. You then need to be able to ingest that data in multiple fashions. You might need to ingest it daily, hourly, in seconds, and often you might need to stream that data. And you have to build out all these capabilities that you see here. Now, the key things is that you always need a data lake house, and this is the ability to read data from raw, curate it into its different stages of quality data from bronze, silver, and gold. It's your medallion architecture. And then basically your machine learning models use those different data fields to create solutions. Some machine learning models require you to use highly processed data. Such other models will require you to just give raw insight so that the model can make the assumptions. And it all depends on your industry, your use case, and what you're wanting to do, and how well you want to control the model that you're planning to use. And sort of on the other side of things is the sort of last pillar that we spoke about, that AI house in its entirety, is you always need to ensure that collaboration is available. People can access this info through portals and web services. It might even be a mobile phone that your consumer is using, or it's an application that you created. So all the stuff that's in this giant house that we try to build up all needs to exit out somewhere. And sort of you'll see the different estates. And like I said, we can probably have a talk at some point, or one of your other lecturers can give you a talk on this full capability model that you need to build out in a fully functioning industry. All right, next slide. So when you're building a machine learning model, there is architectures that we follow. It's all that happens is that we change the blocks to be something slightly different. And it might just evolve, but ideally any good machine learning model has this architecture, right? So we've got two major players in the space, and a third one is sort of part of the journey, is a data engineer and a data scientist. Now, your data engineers, they work with your data lakehouse. They are often the ones that are making data available for consumption. They then ensuring that you've got features, so they make sure your raw data can be used as data for your data scientist. And they then store all that information for your data scientist to consume. So they do quite a lot of work, and they're very key. And in terms of that hierarchy of where work is spent, that 40 and 30% of time and effort actually sits with the data engineers and your governance counterparts. So that, while it only looks like a small piece of work, it is massive in the real world. Looking at your data scientists, they get a bit of the nicer work. They're still very key, and that's why nowadays you'll see people stop calling themselves data scientists and data engineers and sort of call themselves solution engineers, because they need to be both a data engineer at the start of a project, and towards the end of the project, they become data scientists, right? So we need to evolve those skills to be more generalists, as opposed to being very specific and saying, I only build machine learning models, because in the real world, if that's all you're going to chase, there's only 10% of the work for you to do. So you need to make yourself very valuable in the organizations. And what an AI data scientist do, they typically access models that have been equipped and available for them. They would create monitors and alerts. So this is if the model is performing badly or bad suggestions are coming, they create those metrics to notify business. So when we talk about that question you asked of how does business make informed decisions, what governs, it's not just the machine learning model successes that need to be told. It's also when it's not doing well that we bring up to the space. And next is they do all the analytics. They read the data, they understand it, they get familiar with it, they understand how the business flows, right? And you get to do a whole lot of interesting sort of discovery spaces. So again, data engineers work very closely with data scientists. And as we've seen in the sort of new space, is people wear both hats and they just take it off at the time and place. And then you do still have your specialists, because there's a market for people that have tailored expertise, but it is shrinking. And the very important person that any good system builds around is the human in the loop or the human on the loop. So depending on your business and your use case, we always want to have some human validation, right? AI is very good, right? And machine learning is incredibly powerful, but it does need some validation. So someone that's in the industry that's just going to give a quick check to make sure it's not hallucinating, it's not unfamiliar things that are happening. Because as you're adapting machine learning into your business needs to understand that flow and agree with its decision-making process. It's not something that gets to just do it free reign. All right. So when you're going and building things, think of how you build all these blocks into a full-on industry standard. Next slide. So this is typically how we scope our projects, right? The problem statement that came about was, Damien, please leverage AI to analyze data and detect anomalies in privileged access management for databases, addressing functional gaps and replace Guardium, right? So that was the problem they gave me, a one-liner. Now you must just build an AI solution off it. Now, understanding what PAM is. PAM is basically people often use databases in the banks and in any industry, but you're not always allowed to access all the information. You also can't delete certain info. So PAM must basically says you need to always audit people and ensure that it's good. So then I said, cool, let's write up your business objectives. So sitting with business to understand what's happening, we said, cool, they want to minimize breaches on their security network. They want to reduce the number of places people can access info. They want to prevent malware attacks. They want to build good, cohesive, and comprehensive risk security and risk platforms. And they want to ensure that they've got a standard across their entire estate. And basically, in the end, we said, fine, we can build three things out. We're going to establish a secondary landing zone for all your audit data. We're then going to make sure we can log data across every database in the bank. And then we want to go and build an anomaly detection model, right? We want to see unheard of themes. And that's your sort of unsupervised learning that comes into place, right? Is eventually you will build patterns and trends for a given user, right? Ideally, Damien only works from 9 to 5. So if Damien is all of a sudden deleting a database at 3 a.m. in the morning, the chances are it was not Damien. Stop that action. So that's a simple way in which you think about it. And let's look at how we design the system, right? So I think that's where everyone's sort of understanding now where it goes. So if you go to the next slide, this is the very high level system design. We have users that interact on interfaces, right? They might interact on Microsoft SQL Server. They might be accessing it on Postgres. It doesn't really matter. What happens is they execute commands, and these are stored on the database constantly. And that's what exists in the bank. We then said, great, every 30 days, we're going to extract all that audit data from that database because it's a lot of data that comes through. You can imagine every time you guys did your integrated projects and you said select all star, imagine capturing that for every single user in the bank when they're accessing data. It's quite large. So we said, let's extract it, store it on a lakehouse. From there, we connect that to our AI platform, which allows us to build machine learning models. And then from there, all the models, the predictions, the forecast, we're going to display it onto Power BI so that an auditor can see what's happening and as well as business users can interact. So that's a very simple design, right? It sounds very airy-fairy, very easy to build, right? You know, it's just three components. I need a lakehouse, the AI platform, and Power BI. And if we go to the next slide, this is then actually how we build out the solution. So in essence, we've still got all the database administrators interacting with all our different databases. So there's 4 major databases. Note that each of these databases have multiple actual databases entailed. So this is just the product. I think in total, there are 1,500 databases in the bank, right? Quite insane. So imagine it's not going to be something we can manually audit. So what happens is we're going to have something known as a data factory. And this is basically a glue job that goes and pulls that data. Every 30 days, pulls the data out of all of those databases that we've listed and stores them in AWS or Azure's blob storage. Now, depending on the vendor, we choose the appropriate solution. From that, we read all that data using something like Synapse or Databricks, and then we can consume it and build out our feature stores. And the feature stores are like login times. It could be anomaly flags. It could be any sort of feature or column that helps you make an informed decision. Pretty much all of that gets hosted on a model serving system, which is then either Synapse or Databricks or Azure ML or MLflow in Databricks. And these basically read all the data, they read the models and orchestrate that entire process. And they basically push all that into a monitoring solution, which is a front-end interface that any user can log in and see who's doing something weird. On the background, we also have email triggers that notify people as soon as someone's done something irregular. And all of this then is how we, in essence, architect an entire solution, right? So part of this is a team will build an ingestion engine, which is Narwhal's glue jobs. Someone needs to go and create the S3 bucket for us to land data. Then you've got data scientists and engineers that will build out that feature store and work on those components. So that big architecture we showed at the start of all the players come and build out each of these smaller components and work on a system. And what you'll notice is very similar names are here that was on that original architecture. The only thing that's changed is it's more specific to the use case, but we're always following the same principles of we need to read data in, curate it, build models, and produce an output. And that will always be your flow in the real world. It just matters of where you're integrating. So let's look at I think I've got some use cases to show you in terms of some successful projects that we've run through. So the first one up, right? So if you go to the next one, this was a suggested orders recommendation engine, right? Built for Coca-Cola. Basically, we covered 6 countries in Africa. We basically generate 57,000 suggestions in under a minute, right? So every day this thing runs, and in under a minute, it will give you 57,000 suggestions. And this is then going to be scaled out to all 250,000 customers. It takes about 8 minutes to run the solution from end to end, from creating monitoring alerts to reading data to creating a prediction. All of this happens and gets surfaced very much quickly to the end state user. So how does the system work for a normal person? A customer transacts every day, similar to how you buy things on your online shopping apps. But remember, these are customers always buying beverages. So you buy 1 day, 2 days, 3 days, and over time, you've created this history of data. From there, we create certain features. So we extracted the date, the product you were buying, the number of items you bought, how much you paid for it, and where you're based. And then we have 3 models that run. We have a machine learning based model, an averaging model, a seasonal model to build out each of those suggestions out. The best suggestion is then shown to the client. So when they open their app to buy a new order, they can click suggest order, and that suggestion that we created in the morning or every 8 minutes that we generate that suggestion, they can see it and be like, cool, that's actually exactly what I wanted to buy. They can quickly change it on their mobile phone to say, I want 1 less case of Coke. And then this order is then placed. And that whole engine runs through every day. And sort of the benefits we saw was sort of increased in accuracies of suggestions to people. So instead of you needing to always add things to your cart is there. Customers went from taking 30 minutes to order their items to spending less than 2 minutes to order a new item. Basically, we could then push more of the strategic products in the business. We could be agnostic, meaning people could receive orders either via averages. So remember I said 1 + 2 is 3, and then you can get an average. There was different models. So if you wanted to use a more enhanced model, you could use the average model. It all depended what worked best for that client. And all of this is integrated into the sales platform. So you always got feedback to how well a suggestion paid off for you in terms of your sales and revenue. So that was one of our solutions that we built. And I guess the last one that was sort of talked to before I guess we're going to Q&A is service level observability. We want to know what a service does, right? So in the sort of ecosystems we work in, there is 52 services that help someone basically do a cross-border payment. So now you have to integrate across all of these. It currently spans across every country in Africa and about, I think, 20 countries internationally outside of Africa as well. And it's tedious to coordinate everything, and no one wants to use a single tool. Everyone uses something different. So we said, cool, build whatever you want. We're going to build something on top of that and get all the data. So for the first time ever in the bank, we could see everything that someone was doing for a single service. Now, in this case, we then connected our data sources was Splunk, AppDynamics, and Grafana, which are already monitoring tools. The problem is that no one wanted to use one. So that was an issue. So to make it better and to prevent making ourselves evasive to these groups, we created something known as sort of like Ava, which basically has the ability to read information from any monitoring system. So you just give it an endpoint and it pings it. We then log all that data and then we start doing feature analysis. So often when you're tracking databases and services, how they deliver in terms of CPU uptime, database size, volume, throughputs, it's quite weird, right? And often these developers write very funny logs, and a log is like a very unstructured message saying what's happening in the business. So what we said is, cool, we're going to make the logs, chain them together to understand what logs are happening. We run system diagnostics in the background to see if the system is functioning the way it should. And then we created a dependency graph, which says system A speaks to system B, C, Y, and system B connects to A, connects to Z, connects to L. And we basically connected all 52 of these systems together so that if one goes down, you can immediately see what it was impacting around the entire organization. And part of that is then we said, let's make it easier for business to understand this info. So as we said, logs are really ugly, badly written text. We then went and said system failure imminent. We went and changed it to say database overloading. We went to say CPU usage extreme. So all of this then happened in the space for making it easier to interpret machine learning outputs. We then created a metrics engine to say, what does a good system look like? And then we built something called an ARIMA model, which basically can predict cyclic when an event is going to happen. So we can predict when the service is going to slow down, when it's going to increase, and so forth. And again, we had our benefits in the sense. So again, similar thing, customer experience. By us ensuring all 52 systems are operational and up, your customer never fails a cross-border payment again. We made sure we could see when a system is available, when can it be used. And what we're trying to work towards is where it's self-healing. So at the moment, it just predicts what's going to happen. Imagine a world where you can predict what's going to happen, tell the model to go and implement the change that the business should have done. And then it basically, the system never goes down, right? So you don't need that human interaction and you can move quicker through the process. And for the first time, all 52 systems could be seen on a single dashboard, where currently now they're shown across 52 dashboards. So that's sort of where we go through in terms of our designs and thinkings. And hopefully this shows you a little bit of what, I guess, machine learning is in sort of the real world and space. And I guess from my side, I'm done with the talk in terms of showing you what's there. I'm going to hand over back to Lewis and Archie to take you through the rest of the agenda.
All right. Very impressive. Please don't can hear me. It's raining very heavily about here. All right. That was quite a lecture. That was definitely quite a lecture. And I mean, this is the benefit of having someone who has been in academia and now in the industry. When you bring together that wealth of experience, this is what you get. Please, if your hands are not too busy, let's send the emojis. Let's send like 3 billion from yours. And I pretty much am aware that a lot of you have questions to ask Damian. So we're gonna do this, right? You can use, okay, I see some questions already in the Q&A. Please use the Q&A function. And then we'll take just 3 hands. We'll take just 3 hands if you want to ask a question live. We're going to take just 3 hands, and we'll take the first 3 hands, indicate by show of hand, and we'll allow you to speak. But let me start with the first question in the Q&A. Looking how critical knowledge of the cloud, looking at how critical knowledge of the cloud is in data science. Okay. I think this is a very good question for Damian, but I'll just read it out and I'll respond to that. Why have ALX taken AWS out of the data science course? So, while we used to have AWS as an offering, at the moment, it's no longer available as an offering. However, in the future, if at the time, it comes back, we'll definitely communicate that. However, that does not mean that we are not aware, obviously, of how important cloud computing is, right? And like we always advise, there are other platforms where you could, take the AWS Cloud practitioner certification, get the skills required, and also, take the exams involved. So while we do not offer it at the moment, we implore you to pretty much take advantage of other platforms and other, places you can um, learn and get this required skills. But there's still jobs for entry-level machine learning engineers. I'm going to take this to Damien. All right,
Sure.
Damien, Chidimma is asking.
So in terms of, is there still entry-level jobs? Yes, they're often not called machine learning engineers. As I mentioned, we're evolving where you need to be someone that can wear multiple hats. So you're someone that can do data engineering and data science. The niche is starting to fade away because the market's quite full. So we're looking for people that have the ability to be solutions people that can ideate, understand, and learn a skill. So yes, while your speciality, for example, mine is data science, I needed to know very much how data engineering works so that I can work full end-to-end build systems, right? So in terms of an exact job for machine learning engineers, I have seen them. I think they're hard to get because then you're competing with everyone that wants that title of a machine learning engineer. But as you sort of go through the space, look at grad programs and build your way into building machine learning models. As mentioned, it's 10% of the work. It's very, very small. So you need to be very aware that, do people want to pay for 10% or do they want to pay for the 100% of the workload? So they're going to want someone that's well aware of their data, they've got good foundational principles, and that they have the capability to build a machine learning model, but need to know very much how data moves through the journey. And that's where we see the industry growing, is a lot more on the data engineering side, and then sort of having that flavor to learn what data science is and what machine learning is. And there's sort of three distinct fields in machine learning at the moment, and maybe this is just useful for people to know. We've got our traditional machine learning, which is our old school regression, classification, unsupervised learning. It's what you learn in the program. Then you've got agentic AI, which is what everyone is sort of hoping about now, which is that orchestration, seamless integration where the AI acts on behalf of a individual, right? It orchestrates itself and it works. And the third thing that we have is software developers. I think it's quite big and growing now, is through development, they are using copilots. So you're either using GitHub Copilot, you're using Anthropic, you're using Windsurf or something of that nature as an IDE to expose yourself to an LLM. And the new industry standard we're building now is, can we build co-pilots that understand the industry we work in to help our developers code faster, be better, more aligned with our industry? And often we're seeing sort of development time increases of about 30% faster times, 30% better code, and so forth. That's coming out of industry because they're supported by AI systems. So those are sort of the key three work streams that are happening. And hopefully over time, people then start to evolve their toolkits to be more generalist across the board. Cool.
All right, awesome. And Matthew, just to add to just to also add to my earlier response to your question, we now have the data engineering program, which started with 10, and seeing how you're currently wrapping up your data science journey, would encourage you to do also, just like Damien has said, beyond the skill set of the data scientist, you also need to understand what happens in the data engineering part of things. And so yeah, would definitely encourage you to take advantage of the data engineering program. As soon as you're done with the data science program with this master learning track, you also enroll for the data engineering program as well. All right. The next question here is from Mustafa. Mustafa is asking, what makes an ML portfolio stand out for early career candidates?
So through our interviews, I guess the thing that stands out for us is actually seeing someone build end-to-end solutions. So often we see people going and showing us their Kaggle portfolio or their Zindi portfolio, which has them building a model of data, which is good. I think when you're learning for the first time, that's really good to see that you can understand the process of building a machine learning model. But that's a very small piece of the real world. So that fuller picture of, can you demonstrate the ability to find data, to read data on your own, to clean data on your own? That entire journey and that logic of how you process information, That for me is more important. If you can think of your own problem in the world and solve it, that for me is significantly better than someone that has a leadership score on Kaggle. That shows you're very good at machine learning. Does it show me on your portfolio that you're understanding that in the real world, you're not just going to have a data set that you click pd.read? No, it doesn't show me that. So that is something quite important to understand, is we want to see what more you bring to the table, because it's a very competitive industry. So yeah, in terms of standing out, end to end, show me that you can start from data source, extraction, clean all the way through.
Awesome. So guys, this is your cue to start building those end-to-end projects. Alrighty. Chidinma is back with a question, and Chidinma is asking, what jobs I see require people with statistics background? How can someone with a healthcare background break in, and how long will it take to learn to be a solutions engineer, like you mentioned? And where can we find small jobs so that we can begin learning as we go?
So without knowing full context of everything that's involved, so with a lot of the jobs, yes, it's typical they want stats because that's what the recruiters look for, right? And being able to network and go to events is also quite important. I think there are often free events where you can meet people that are in industry that are hiring, that are going to let you chat to them before they ask you what your CV is, right? And that's a good way to get known. I think that's very important, is building a brand. So when people see you and they see you coming, they go, oh, okay, I like it. I like what I can see, before they look at your CV, right? And that's something quite important that you need to look at. If you've got healthcare background, there are a number of healthcare industries that are trying to break into the space now, where they're trying to utilize their data more. And just recently, we did a monetization strategy for a company in terms of how do they take this huge amount of data they've created over the years and build solutions that they can make money off of, right? And the most simplest thing we did was show them product journeys, right? So we showed them how much does it cost for a patient to undergo a certain treatment plan. And we created a dashboard to show how much it costs in South Africa, how much does it cost in the UK, and how much it costs in the US. That very basic, the data was all there. All we did was put filters in and we put that on a dashboard. That solution was sold for about 15 million. Nothing crazy. It just showed how much it costed per country. No patient's data was shared, nothing of that level. It was all aggregated. So you just need to find the niche. You need to find who's doing the tech. So stuff like companies like Altron Health and sort of these pharmaceutical industries are eager to go into the conversations. Yes, there's those high gate walls in terms of the titles that they're looking for. But I think if you meet the right people, you can get into the right industry. And it just takes time in terms of how